My name is Rob Bowers. I'm an experienced engineer, and I've spent the majority of my career working in Atlanta. This is also where I spent my childhood growing up. And as a child, one of my favorite things to do was to play with Legos. I used to take all the different boxes and all the different kits, and I'd throw them in the middle of the room, see what types of different things I could make, what types of unique solutions I could come up with from the various pieces. And this activity would carry me forward to a career in technology. And I think all of us here today are still playing with Legos. It's a lot like being a solution architect or a full-stack developer. We're choosing platforms, we're choosing frameworks, we're choosing different libraries, and piecing them together to come up with a unique solution. And you might be wondering if this is a picture of me, and it actually isn't. I couldn't find a picture of myself playing with Legos. About 6 weeks ago, as I was preparing for this presentation, I called my father and I asked him, I said, "Dad, where are the pictures of me with the Legos?" And he said, "Well, we have the pictures, they're in the basement." So I said, okay. The next time I went and visited, I went down in the basement and I found those pictures. Do we all remember these? Slide carousels? This is how my dad stores his photos. And I might be dating myself a little bit, but it wasn't that long ago that we used to do things like this. And this is how we dealt with our photographs. But today I can just ask my phone for any photo I need, and it will give it to me immediately. Everything is stored in the cloud. When we take a photo, it's spread across all of our devices automatically. And now with facial recognition, I can have an album created of myself, also automatic, without having to do anything. And as a technologist, we all have had a front row seat to witness how quick things are changing. Just look at Amazon. Does anyone remember that Amazon used to just sell books? Pretty soon, we can just have our virtual assistant sitting in our living room and asking for anything we want. And we will have it delivered to our door through the sky by a robot. Just think about the incredible things that Amazon has been doing to change our lives with technology. This building is Amazon's headquarters, and Jeff Bezos, the CEO of Amazon, named this building Day One because he wanted to remind his employees to always think like a startup, to have an eagerness to adopt new trends, willingness to experiment, and desire to make quick decisions. And this mindset has taken Amazon to one of the most transformative companies in history. But there's only one Amazon. And the reality is that all businesses today are being affected by this flood of technology and by this exponential rate of change. And you're seeing that firsthand here in India. Think about how quickly the digital payment space has disrupted financial institutions with the entrance of companies like Paytm. And it's not just the banks. Think about the street vendors and the small shop owners and how it's affected their lives. And another one of these competitors, MobiKwik, is soon to become the 12th member from India in the Unicorn Club. These are private companies valued at over $1 billion. These are the disruptors. And if you look at the acceleration in the last 8 years, it is absolutely astonishing. From 2009 to 2013, we've seen 23 companies enter the Unicorn Club, and just the last 4 years, 162, soon to be 163 companies. But what do these companies have in common? Does anybody know what this graph is? I'm hoping not. It's a trick question. There's no labels. I decided to overlay the year-over-year revenue of Amazon Web Services on top of this chart. And I think the growth curve matches up pretty well, don't you? But I don't think it's a coincidence, because these companies are born in the cloud, they're built for the cloud, and they're growing with the cloud. And so we all know that the cloud is breaking down barriers to entry. It's allowing companies to move faster, respond to their customers faster, and innovate faster, and also do it at a lower cost with a smaller team. But when you think about this, what is the mission of the cloud? I think in simple terms, the mission of the cloud is to abstract away unnecessary complexity, to allow businesses to focus on only what matters, on only what is a differentiator, and only what makes them competitive, and let the cloud provider manage the rest. And we've seen this trend throughout the history of cloud. Physical servers in your data center, and then we move to virtual servers in someone else's data center. And finally, we move to the cloud. And we did this because we don't care about hardware. We don't care about operating and maintaining servers. And we don't care about operating data centers. Manage it for me. And the cloud providers are consistently innovating in this space. They're continuing to build out massive data centers, modern-day power plants. And as these trends continue, soon infrastructure will be automatic. It'll be invisible to us, just like a utility. And so the cloud is becoming all we want, right? I don't think it is. I think the cloud isn't solving the majority of our problems. How many people in this room are application developers, server-side developers, or front-end developers? Okay, it's about half. That's what I thought. That's great. How is the cloud solving your problems? Think about the typical application stack. Cloud is doing a pretty good job solving for these bottom two, right? We can get infrastructure stood up pretty fast. We're really good at DevOps. We've got build and release down. Isn't that the easy part, though? Think about all the challenges around dealing with complicated business logic, application code and frameworks, and integration with presentation layer. That's the hard part. So we need to evolve cloud up the stack to allow us to move faster and be more efficient. Okay, so we solved the top three. Now we're good, right? I don't think so either. Even the stuff that cloud is solving for, I don't think it's doing a good job. In 2017, it's estimated that the worldwide cloud spend of infrastructure will be about $100 billion. $40 billion is wasted on over-provisioning servers and accounting for peak traffic, which may only hit once or twice a year. General mismanagement of resources, and having this mindset that, okay, we're going to go to the cloud, I'm just going to put my code in AWS and think they're going to manage it. It doesn't quite work like that. And if we project this out just 3 years, that's almost $65 billion in wasted spend of infrastructure. There's 117 countries on the planet with a GDP lower than this number. Think about that for a minute. $65 billion. So we need to look at our approach to cloud from a new perspective. We need to innovate up the stack, and we need to stop wasting resources which could be put elsewhere. Because I believe that the future of software applications will be built on infrastructure as a utility and code as an afterthought. So how are we going to do that? I believe this is where we start. Focus on the smallest unit. Focus on what really matters to a business, and let the providers manage the rest for us. Many of you here today are working in large monolithic applications. We've been building these for 10, 15, even more years. These are probably running maybe in an on-premise data center, maybe even a mainframe, or it could be in a virtual machine in the cloud. And many of you also here today are trying to break down that monolith into distributed microservices in order to gain the efficiencies and agility that we know that we can get from this paradigm. And these microservices are probably running inside of a container, maybe using technologies like Docker. But what if we break down these microservices even more? What if we take them and break them down into individual methods? And what if we take those methods and put them inside of a container? And we know this now as functions as a service. And it has another name. Many of you have heard the term serverless. And if you're like me, I think you agree we need a new name. Because there are servers, there are millions of servers. We just don't care about them anymore. A couple years ago, Amazon started the movement of functions as a service with the advent of Lambda. And all the leading cloud providers have now followed suit. Google Cloud Functions and Azure Functions, just to name a few. So let's quickly dive into functions as a service and see what are the 4 key characteristics. The first is the smallest unit of code. I talked about it earlier. These are the methods, the single methods in your application. These could be small, 20 to 50-line code functions. And they should be designed to do one thing. They receive an input, they perform an action, do some business logic, and then send the output. The second is event-driven, executed on demand. Functions run from a push-trigger mechanism. For example, if I drop an image into a cloud container storage solution, we trigger a function. If I write a record to a database, we could trigger a function. If I hit an API gateway, we could trigger a function. And they're executed on demand. I mentioned these functions live in containers. And so now these cloud providers, when these events fire, they spin up the container, execute the code, and then spin it back down. Completely on demand. Automatic scalability. We no longer have to have servers running, since we can now spin these up and spin these back down. And because of this, it's infinitely scalable, up or down, depending on the needs, and depending on the traffic. And the fourth one, which I think is the most overlooked benefit to this technology, is pay per execution only. So when your function is running, you're getting billed. When it's not running, you're not getting billed. And to put this in perspective, a traditional container application, EC2 maybe in Amazon, charges you by the hour. Lambda charges you by 100 milliseconds. And Lambda gives you 1 million free function executions per month. Each additional million is 20 cents per million. So we now have these 4 key characteristics. Let's take a look at an example on how this plays out. So I'm going to take you guys on a trip. We're going to go to Australia. And every 5 years, the Australian government does their census reporting. And in 2016, they decided they were going to go digital. They decided they would build a website to where all the citizens of Australia would log on, hopefully not at the same time, and fill out their information, and now the government has the data they need. It didn't quite work like that. Hashtag census fail. This became viral throughout Australia because this was a complete disaster, a comedy of errors from the beginning. Servers crashed within 2 hours, and the government was never able to get all the information they needed. This cost them $10 million. $400,000 of that was load testing alone. 2 weeks later, 2 eager developers entered a hackathon, and they said, we're going to do census right. So they developed a serverless architecture that essentially mimicked the website exactly how the government had it, except they did it the right way. They did it with serverless. They load tested it. It could withstand 4x the traffic that they actually needed. And how much do you guys think this cost? $500. And the craziest thing about this story is that these 2 developers had no experience with AWS, had no experience with serverless, and was able to do this in 24 hours. This is unbelievable. $10 million versus $500. Think about that for a minute. So how did they do it? They took the static assets, the HTML, the CSS, the JavaScript. They dropped it in an AWS cloud storage into an S3 bucket. So the user hits the form through the browser, submits the form, we post to an API gateway, we then trigger a Lambda function, we then write the data to DynamoDB. Pretty simple, right? Simple. Should be simple. So you can see this entire architecture, they didn't have to manage servers, they didn't care how many people hit it at the same time because it scales immediately, automatically. And you'll also see there's a lot more going on here than just a Lambda function. This function was maybe 15 lines of code. So what is serverless now? I thought it was just functions. So we need to think bigger than just the functions. Serverless is an ecosystem. It's a highly productive, event-driven, cloud-native platform for developing applications. So let's look at this ecosystem. And I think there's 2 parts to it. And these 2 parts are really held together by these functions as the glue to your application. So first we have cloud managed services. These are things like S3 and DynamoDB like we saw earlier. But the real competition with the cloud providers these days is to innovate in this space. And it's happening faster than you can imagine. Last year alone, AWS released 1,000 different services. That's something like 3 per day. I didn't do the math, but it's close to 3 per day, right? It's incredible. And it's not just database, it's not just storage. It's everything you need to run applications. It's orchestration, DevOps, data, monitoring, analytics, Internet of Things, which NR will be talking about later. And then on the other end, you have backend as a service. And we've seen over the last couple years this influx of software companies who are built in the cloud. Many of them are the unicorns we saw earlier. And they're giving us services which makes it easier for us as developers to not have to worry about a lot of the complexity that goes into our development process. Think about things like authentication. I had a client recently, they wanted to do authentication in their system, and we estimated 160 days to do that work. With Auth0, we could probably do that in a matter of 10, 12 days. We also have things like payments, messaging, email, search. And these are just a few. And the onslaught is coming with these software companies. And the things that we can build with this ecosystem. We can build entire serverless backends. But it's much more than that. We can now build serverless workflows and augment those on top of our existing architecture. And a lot of different use cases have been surfacing. But I think the use cases are limitless. And we can get creative in the things that we build. Let me give you an example. Like I said, I'm an experienced engineer. And one of the things I'm really passionate about is a seamless process across domains. Things like build and release through to application developers, QA, creative. Having this seamless process, you all know, is very difficult. It's not easy. So let's take a look at a simple scenario and how could we solve this with serverless. So you have a build. We want to build to an environment. And then we need to do QA testing and creative QA as well. Let's do this with serverless. So your build completes, you build to QA. You then trigger a webhook up to an API gateway. We trigger a Lambda function. We write the application URLs to an event queue. One by one, we take each page, trigger another Lambda function. That function goes out behind the scenes, takes screenshots at all the responsive breakpoints, and writes those images to your project's box folder. Pretty cool. What if we could then hit the Jira API and add your QA stories? And then at the end, we can send a message to all the teams saying, Jira is ready to go, and the screenshots are in box. So this is just a simple way that we can solve some of our common challenges. And this doesn't have to be an entire back-end architecture. These are workflows which solve problems for us and enables us to move faster. So this will lead us into this new wave of workflows. And we can take these and package them up into templates. We can drop them into all of our different applications. And so the major cloud providers have estimated that in just 3 years, between 50 to 60% of workloads in the cloud will be serverless. Think about that for a minute. 50% of everything in the cloud, those workflows will be serverless. And there's a lot of innovation happening. There's frameworks. Many of you have probably heard of the serverless framework, where if you're a developer on your local machine, you can do your development and easily push your functions up to the cloud, up to your cloud provider of choice. But there's a lot of innovation ahead in these tools, because currently they do a good job. They'll get your functions to the cloud. But when it comes to architecting and piecing together all these services, that's where the challenge is. And quite frankly, if you've ever logged into AWS and tried to configure this stuff, it's not that easy. And so these tooling frameworks are really going to help us with that, and we can expect a lot of evolution with this regard coming very soon. And when I talk to people about serverless, they'll often say to me, well, I can't figure out, it's breaking here, I don't know how to monitor it, how do I debug it? You know, we've got functions calling services, calling functions. How do I deal with that? And so recently, AWS released a tool called X-Ray. And this is a tool where you can monitor distributed applications and trace your request throughout the entire workflow, see the inputs, see the outputs, see where they fail. You can view service maps, and you can analyze issues. So there's going to be a ton of innovation in this space moving forward. And so what is the future going to look like with these architectures? And I know what many of you are probably thinking, we're going to have functions all over the place. Isn't this going to be complex and complicated? Aren't we going to be rewriting functions from this application to this application? I don't think so. I think we're going to see a marketplace, a serverless marketplace consisting of individual functions, generic enough that they can be reused across all of our applications. And also serverless workflows that can be augmented on top of our existing applications and built into our new ones. And it's not just enterprise functions, you know, within a certain client or within this organization. This could be a community marketplace consisting of other people writing functions, other people creating workflows. Imagine what we could do now and how fast we could move just by doing configuration of these things in the marketplace. And so I think instead of thinking about these as serverless applications, I think we need to think about these as service-full applications. To where we're now going from an era of replication to configuration. Cloud-managed services, functions as a service from a marketplace, serverless workflows, and of course, our backend as a service to make things much, much easier for us. This is code as an afterthought. And I think this could get much more interesting. If you think about serverless as a utility-based system, you only pay for the compute time. Imagine now, instead of us writing functions which will then hook into these external services, for example, we have a function that integrates with Stripe for payment. We might write 10 Lambda functions for each of the different things that we could do with Stripe. Now, what if Stripe was also serverless? And what if Stripe could expose their functions to us? And all we do is we trigger, anytime we need to do anything, we trigger to their functions. And if instead of us paying licensing to these companies, we now just pay for what we consume. So our Amazon bill at the end of the month might contain our compute time for Lambda, our compute time for authentication, our compute time for payment. No more licensing, all utility. So as you go forward, my ask of you is to embrace these concepts. Not just for yourselves, but for your clients and for those businesses who are being disrupted. And think about all the challenges that you face every day in your projects. And how could those be solved with serverless architectures? We all remember Amazon headquarters. The building's name is Day One. In a recent shareholders meeting, an employee asked Jeff Bezos, he said, "What does Day Two look like?" And this is what he said. Day two is stasis, followed by irrelevance, followed by excruciating, painful decline. And that is why it's always day one. And so your normal ways of working in the outside world can push you into day two. But if you embrace new trends, have a willingness to experiment, a desire to make quick decisions, you can now have a tailwind. And as you'll see in the rest of the presentations today, this tailwind is taking us into a new era of intelligence. You heard Sunil talk about it today. And if you look back at those unicorns, you better believe that we're going to see another wave. And these are going to be companies, software companies coming in, offering artificial intelligence as a service, machine learning as a service. And now we will be set up with our architectures to be able to plug in to these intelligence services and pay for them as a utility. Think about how much faster and how much smarter we can move then. I'll give you an example. Let's go back to that QA and testing scenario. What if we could then plug in machine learning as part of that workflow? And then what if we could take Photoshop documents, wireframes, business requirements documents, run them through a serverless workflow, and on the other end, you could have fully built front-end components, fully built CSS, fully built JavaScript through these serverless workflows, enabled by this new wave of intelligence. And so you would now have the best of everything as a service. Now we have what we've always wanted from the cloud. And so I can't wait to see what you will go build. Thank you.